Let's see the examples. Example 1. An open rectangular rattan case with square base is to be made from 48 cm square of material. Find the dimension of the case that will make the volume maximum. Then find the maximum volume. First step, draw an appropriate figure. Let variable x be the length of one edge of the square base and variable y be the height of the box. The surface area equals to x squared plus 4xy equals to 48. Then y equals to 48 minus x squared over 4x. Substitute y into the formula v, so we get 12x minus x cubed over 4. Find the value of x when dv dx equals to 0. So we get x equals to plus minus 4. Choose x equals to 4 since the variable x measures a distance. To determine maximum and minimum, we find the second derivative of v. So at x equals to 4, we get the negative value, means it's a maximum volume. When x equals to 4, y equals to 2. So the dimension of the case are x equals to 4 and y equals to 2. For maximum volume, we just substitute x and y into v. So we get v equals to 32 cm cubed. Example 2. A box with an open top to be constructed from a square piece of cardboard 3 feet wide by cutting out a square from each of the 4 corners and bending up the sides. Find the largest volume that such a box can have. Let variable x be the length of one edge of the square out from each corner of the sheet of the cardboard. After removing the corners and folding up the flaps, we have an ordinary rectangular box. The volume of the box equals to x times 3 minus 2x squared. Expand equals to 9x minus 12x squared plus 4x cubed. Find the value of x when dv dx equals to 0. So we get x equals to half and x equals to 3 over 2. To determine maximum and minimum, we find the second derivative of v. At x equals to 1 over 2, we get negative value, so it's maximum volume. At x equals to 3 over 2, we get positive value, so it's a minimum volume. So the largest volume at x equals to 1 over 2, we get 2 feet cubed. Example 3. A container in the shape of a right circular cylinder with no top has surface area 3 pi feet square. What height h and base radius r will maximize the volume of the cylinder? First, draw a figure. The area of the cylinder equals to pi r square plus 2 pi r h equals to 3 pi. So we get h equals to 3 minus r square over 2r. Substitute h into v, so we get 3 over 2 pi r minus half pi r cubed. Find the value of r when dv dr equals to 0, so we get r equals to plus minus 1. Choose r equals to 1 since r measures a distance. When r equals to 1, h equals to 1. To determine maximum and minimum, we find the second derivative of v. So at r equals to 1, we get negative value, so it's a maximum volume. So maximum volume at r equals to 1 and h equals to 1.
Created using Powtoon.